Hello everyone. Our team today, we are going to introduce the alpha magnetic spectrometer 02. And this is our outline. Today we have the three steps. The first step is history of the MAS02. And the second step will introduce the design of the alpha magnetic spectrometer. And the final step, we will go to talk about the science goals and the results. And now we are go to the next first step. The history of the MAS02. The alpha magnetic spectrometer was proposed in 1995 by MIT particle physicist Jin Shouzhong. Not long after the cancellation of the superconducting supercollider, the proposal was adopted and Tim became the principal investigator. And these two pictures are the NS01 and STS91 sign. And then MS prototypes designated NS01, a simplified version of the detector, was built by an international consortium under team direction and brought into space aboard the Space Shuttle Discovery on STS-91 in June 1998. And they found nothing much, so by not detecting any anti-helium, the NS01 it reached the upper limit of 1.1 multiplied by 10 minus base power for the anti-helium to helium frost ratio and prove that the detector constantly working in space. And after MX01, in 1999, after the flight of the prototypes, the team began the development of a full research system designated MAS02. These developments involved the work of 500 scientists from 56 institutions and 16 countries organized under the United States Department of Energy sponsorship. And the post-space shuttle Columbia plan was to deliver MS-02 to the ISS by space shuttle in 2005 on station assembly mission UF4.1. But unfortunately, the technical difficulties and the shuttle scheduling ensues and more delays. These two pictures, the space shuttle Garibia disaster, and I think these are my reasons that made more delays. This disaster impressed me because I still remember in February 1, 2003. I was a 9-year-old kid, and that night was the Chinese New Year late night, and I stayed in the living room and watched the TV program. That's the special New Year's program, and I noticed market news displaying of the display of the right of the TV screen, and the news say this is that I remember this as the Columbia, and the space shuttle Columbia will disintegrated. This disintegrated when it's right back to the Earth, atmosphere. And because this disaster, the NASA recalled all space shuttle back to check any potential problems. And after 2 years since this disaster, the first space shuttle launched and continued their mission. So this disaster is my reason. And then MS-02 successfully completed final integration and operational testing at CERN in Geneva, Switzerland on December 14, 2009. And after that, the MS-02 arrived at ESA test center in the nucleus to undergo thermal vacuum. To undergo thermal vacuum, electromagnetic compatibility, and electromagnetic interference test on February 16, 2010. And on April 16, 2010, after evolution of the ESTEC test results, the participants to the Technical Interchange Meeting, ITM, the scientists agreed to a permanent magnet configuration. And so the MS launch would therefore move to mid-November. And after that, the MS-02 arrived at CERN from ESTEC and was put in the clean room where it underwent magnetic switch on April 29, 2010. And this is I remember this is a permanent magnet, and this is AM-02 and was put in the cleaning room. And departed from Geneva Airport. MS-02 arrived aboard the U.S. Air Force aircraft C-5M and Kennedy Space Center on August 26, 2010. And according to the design, the power requirement for MS-02 were thought to be too great for the particle-independent spacecraft. So MS-02 was decided to be installed as the internal module on the International Space Station and use the power from ISS. And finally, the STS-134 space shuttle EDIBOT launched on May 16, 2011. And after 2 days, MS-02 was delivered to the International Space Station on May 19, 2011.
I'm going to introduce the ANA, the alpha magnetic spectrometer. The ANA's mass is 8,500 kilograms. Power is 2,500 watts. Internal data rate is 7 gigabytes per second. Data rate to ground is 2 megabytes per second. Previous mission duration is 10 to 18 years. The magnetic field intensity is 0.50 Teslas produced by 1,200 kilograms. permanent magnet. This magnet is neomagnet. It's a powerful magnet. And this is the NX. And this is the superconducting magnet. The magnet is the heart of the NS experiment. Thanks to the magnetic field, NS is able to separate matter from antimatter. In addition, from the radius of curvature, it is possible to estimate the particle momentum. This is the ARD. ARD is called TRD is called transition radiation detector. The transition radiation detector, TRD, its goal is to identify particles through the detection of the X-rays emitted by light particles. This feature is TOF, called time of flight. The time of flight system is the NS Stargauge system. Stargauge is called Mabiao. It is able to measure with a high level of precision, 1.5 10 minus 10 seconds. The particle transit time into NS. The main TOF goal is to wonder are the other sub-detectors of the incoming of an incident cosmic ray. This is silicon tracker. Silicon tracker. The silicon tracker is the matter and the antimatter hunter. Tracker is the only sub-detector able to separate positive particles from negative particles from the direct measurement of the trajectory deflection. The curvature measurement allows the particle momentum and the incoming direction determination. This period is RICH, called ring imaging Cherenkov detector. The ring imaging Cherenkov detector estimates the particle's velocity with a high accuracy, 0.1% velocity derived from pattern recognition of protons distributed over geometrical shapes as cycles, ellipses, arcs, or crescents produced by the Cherenkov effect. This is ECL called electromagnetic calorimeter. The electromagnetic calorimeter ECL is a heavy brick equipped with instrumentation. Incident particles interact in such a dense material, producing a shower of low-energy particles. The shape of the shower identifies the particle kind, proton or positron, and the particle total energy. This visual is ACC. It's called anti-coincident counter. The anti-coincident counter ACC is the NS Cerberus. 10,000 particles per second pass through NS. ACC discards 80% of these particles and save the ones useful for the physics and analysis. This visual is TAS, Tracker Alignment System. Tracker Alignment System is Chinese is 那个轨迹的那个矫正系统。Tracker Alignment System checks the stability of the tracker alignment. This feature is the star tracker and the GPS. NS can determine the photon energy using ECL single particle mode or tracker pair production. the arrival direction with respect to big star using the star tracker and the coordinated universal time UTC using the GPS system. Its nature is electronics. The number of electronics channels in ALS02 300,000 channels is equivalent to all of the ISS electronics channels combined. ISS is 那个国际太空站. This large amount of electronics is needed for the correct operation of ALS02.
And the scientific and results. There are four major scientific goals in the antimatter, dark matter, and the stringlet and the space radiation environment. And AMS-02 will use a unique environmental space to advance the knowledge of the universe and lead to understanding of different regions by searching the antimatter, dark matter, and measuring the cosmic rays. And the first, antimatter. Experimental evidence indicates that our galaxy is made of matters. However, scientists believe that there are about 100 to 200 billion galaxies in the universe, and some versions of Big Bang theories of origin of the universe requires equal amounts of matter and antimatter. Theories that explain the appearance of asymmetry violates other measurements, whether